All right. So, welcome everyone to tonight's session in Quantopian Book Conversations. And we are very pleased and honored to have Stefan Jansen with us tonight to talk about his book, Machine Learning for Algorithmic Trading. So the book is a PACT publication. I have the copy I'm looking at is the second edition. I believe it came out in 2018, and then in 2 years, right? In 2 years, it had a second edition, and we got
Yeah,
an
that's right.
yeah, yeah, that's fantastic, fantastic. And it's a Bible like, I mean, you must see that it is a thick book. It's a very nice book, but we will get into the details. So, welcome, Stefan. Thank you very much for being here with us. And why don't we start with the inspiration, genesis of the book? What was really the reason that you decided to write this book? How did it come to be? When did the project start? So this process of book becoming what it is now.
So one of the drivers behind this was that I had been teaching data science and machine learning in New York for a few years, just some sort of evening classes, General Assembly at the time, which was quite popular. And being in New York, there were always quite a few people that came from relevant, financial institutions like Bridgewater, Goldman, Millennium, etc. And it always turned out that the course was fairly general, and I had been working. So we started an investment firm in 2013, and I was the partner building the data infrastructure, the entire analytics piece, including machine learning and the like. And so, coming from the field, you know that the domain is a little peculiar in many respects. The data is unique. You need to know a lot of, yeah, need some domain specific knowledge, and then you will like adapt your approaches. From the generic, let's predict sales or identify the different cluster, the iris flowers and the like. So the idea was to kind of do a domain-specific introduction to machine learning, and then one thing came to the other, and eventually it started in 2018, and then
Okay.
it became fairly popular because it seemed like it was kind of the right book at the right time. Machine finance was a little behind, I think, in adopting compared to some other fields, but at that time there was a lot of interest. So
Mm.
so yeah, and so there wasn't that much out there. There was of course Marcos Lopez de Prada's book, which was it's sort of more technical in a way, but less hands-on, So that book, my book, kind of filled that, bridged a little bit the
Yeah.
gap there.
Yes, yes. No, I agree completely. I mean, it in 2018, actually, his book also came out in 2018, Kos's book, that is. And you're absolutely right. We are currently offering a course on Quantopian that is based on that text as a textbook, as one of the textbooks, which has really taken over the other textbook because the amount of detail that one has to go in, especially, this idiosyncrasies of financial data, the specific nature of things that go on, basically takes you like almost third of the book, his book, to get to a point where, according to his view of things, you are at a point where you can confidently go and say, okay, now I want to analyze the data because I have
Yeah.
avoided this, I've avoided that. But what wasn't there is exactly a book like this, and what wasn't there is exactly a book like this that goes over so many topics, in one place. So it is a really a wide spectrum for those who haven't seen, if there is such a thing. I mean, I'm sure everybody has seen, but for those who haven't, let me just tell you that it starts really with basics of machine learning and financial data, and then all the from portfolio optimization, feature generation, time series analysis, regression methods, Bayesian machine learning, to even, which is a topic that I want to talk in more detail with you about, the natural language processing, which is chapter 14, 15, even summarizing the data, sentiment analysis,
Yeah.
and all that, all the way to neural nets and deep reinforcement learning. Later, I think from this book, another book came out by Igor Halperin and Dixon and another co-author,
Yeah.
which was on reinforcement learning, essentially. Not quite all of it, but like main ingredient there was reinforcement learning. But again, there is nothing this comprehensive. So, given that this, was there a challenge particularly? Which parts of it do you think that were more challenging to you as the author of the book?
Many, I mean, one of the sort of trade-offs or little conflicts that one faces, of course, is data itself, because
Okay,
free data
come on.
is few and far in between. And so on the one hand, you want to make it accessible so that everybody can play around with it, but at the same time, there's also a minimum sort of bar that you want to jump over so you have sufficient quality, you know. So I think more broadly, I think the topic is tricky because it's very seductive.
Totally.
Like, oh, gonna read the book, gonna make a quick buck, and then it turns out that it's actually quite challenging to get this right. So, it's on the one hand to make people curious and get them to, actually try out a few things. And on the other hand, not to be overselling the point that, this is, like some people have the cookbook and, here are few recipes and, and you're ready kind of to double your money overnight. That kind of stuff doesn't really work.
Right.
So I want to avoid that, but I also didn't want to kind of be too ivory tower or abstract or only for sort of the chosen few. So it's kind of tricky how you bridge that, and I'm not sure that I managed to do that successfully. But that was kind of the spirit behind it.
I see. No, no. I mean, as far as I haven't read all of it, I have read roughly half of it, but not sequentially.
Wow.
But I think really that the parts that I have read that exactly has that balance that you're talking about. Now, of course, if the instructor wants to go and bring in all the theoretical underpinning ideas and methods and theorems and facts and all that, fine. There is room to do that as an additional component. But it has enough dosage of the theory and practice that one can confidently get and say, okay, so I just want to cover this. I don't want to add to it or subtract from it. Maybe subtract because of time issues and so on and so forth. But,
Yeah.
or yeah. So no, in that sense, I think that that's why I really like this book. And there are others that again partially come close, but never really quite with this comprehensive package in one place. So was it the same in the second and first edition in terms of the material you added or took away, or is it that you changed some things from first to the second?
I mean, so the second grew quite a bit. I mean, the
Ah,
first one was the process of the first edition was a little messy.
yeah.
The publisher, has its process of, churning out a lot of books, as you probably know, and I think everybody else also. So I think that they throw a lot of stuff against the wall and see what sticks. So the first book kind of, and then so they're very like deadline oriented, and for me, this is kind of a side project, right? I'm neither an academic nor mainly an author. So the first book, and then also that there was very little editorial real like support, right? So you write the first book, and then it gets longer and takes a little, so it gets like longer in terms of content and takes longer in terms of time, and then they literally go out and then they publish this regardless on the given day with like 4 chapters not being there, and they just get like published as a PDF online somewhere,
Oh,
so that's kind of one way of doing this. And but then it turned out that, as I said, the time was kind of right, and also because I had a bunch of code on GitHub, that people got interested, so it sold for their, it's not Michelle Obama, but for the little niche, it sort of was a good selling, a well-selling book. So
right.
for me, the second edition, that I think the ambition there was a little bit like the first one, to cover the basics, but to also take folks sort of to the research frontier a
Uh-huh.
little more, which in 2019, 2020, I think we sort of published like in August 2020. So by then you had more actual like sophisticated researchers doing stuff in finance, like Brian Kelly, Yale, and others, So that was interesting. So I sort of replicated some of their stuff. There was this like time GAN, synthetic data idea, So to
Yep.
kind of do a few more things than the run-of-the-mill, here's your linear regression or some gradient boosting kind of stuff, to show people like where the journey could go if you start to adapt architectures, as you have in many fields. You take a neural network and then you start adapting the architecture to the specifics of the domain. Like in finance, you have a factor structure, so maybe it makes sense to also try to have something that's like an autoencoder that compresses the data and sort of reflects some thinking about the field, like envision you have convolutional networks because obviously, local kind of spatial aspects matter with pixels, etc., or the transformers in language and so forth. So yeah, so that was kind of a more advanced idea that I also wanted to include, so that the book grew a little bit in that direction. And I also started working with AlgoSeek to include more like higher frequency data, so that like minute data. The third edition, which is sort of in the works, that would cover
Oh, okay.
more like, yeah, so we talk about that. I haven't said about much about this in a while because I've been pretty busy. But so there would be more like higher frequency data, including tick data,
Okay.
because I think that is pretty relevant these days, the whole order book kind of stuff. So yeah, so that's broadly, kind of what got added in the second edition. Yeah, and then of course we had the incident that Quantopian appeared in the book
Yes.
and then closed and then disappeared 3 months
Yes.
later. I mean, it didn't have a very prominent role. Really, I think there was just one notebook that really used their platform. But of course, it relied on Zipline and AlphaLens
Sure.
and all that. So there was that, and which ended up becoming a little bit my project. So I ended
Right.
up
Right. No.
maintaining those a little bit, but of course also for reason of time, not too actively. But yeah, long answer, but that's the main story here.
So that's really great to both points. And I want to, before going to the next question, I want to talk about those 2 points. So the third edition, do you think that there will be more on market microstructure and those type of ideas?
Yeah.
Because you mentioned limit order book and the high frequency data analysis. So that will be then a couple of chapters that will be added to this, you think?
Yeah, so I think I've written and rewritten sort of the first 5 chapters, kind of. So it's pretty much like a new book. I mean, obviously the same topics, so some you sort of recognize the themes, but so I cover many more asset classes. So it's not just like daily equities, but so you had tick data in the first and second edition
Yes.
as well, right? There was this example with Nasdaq and all that. But now I'm actually using, so you have like Data Bento as a good provider that allows
Yes.
you to kind of pay as you go tick data. So there's more of that. So you can also do more of the sort of tick to bars kind of, conversion. You can talk about different features. I talk about features a bit more systematically beyond the typical value momentum kind of ideas. So yeah, market microstructure features prominently. But then also there's like crypto and a bit of
Okay.
futures and all that, right? So I just like try to kind of cover these things a little bit more broadly. That's again, it's a tension because the broader it gets, the harder it gets to also get a little bit more, beyond the surface. But when I talk about features and alternative data, then for example, I talk about like blockchain data, right, as an alternative data source or fundamental, however you want to call it, in the crypto space and so forth, to make it more interesting and also to kind of show people there's a little more than US equities in the world. Like
Certainly.
there's FX, I cover FX a little bit and all that. So
Certainly true. Going back to the other point, Alpha Lens, Zipline, do you see merits in still going on with activities as such as a community? Do you think, I mean, right now, of course, Quantopian is in a different form. Quantopian came back in December 23 as a community and just
yeah,
a community. So there is no trading part, there is no algorithmic competition part, there is none of that.
yeah,
But this whole idea of providing the regular people, let's say, for lack of better term, providing the layman, providing the regular term with tools that can bring them close, not quite, professionals, and implementing things like this. In addition to the lectures, in addition to experimental things and notebooks and all that, do you see place for this still? Like things like Alpha Lens that may be of importance going forward?
I mean, there are a few tools out there, like the Y Finance guy also has like
Yes.
quant stats. And I mean, implementing like basic financial kind of measurements, metrics, and all that. I mean, if you play in the field, you should also be able to do that yourself relatively quickly. And I think many people sort of, roll their own thing.
Mm.
It's always a disadvantage if your library wants to be like too sophisticated, then very often is very tailored to certain use cases. As always, like the whole, like the portfolio of all these like tear sheets, which like they were really like nice when they came out. But of course, today they're not really state of the art, like visually and all that. So yeah, so. I think the ecosystem is alive and well. I mean, so instance, I would be covering also like vector BT and talk more
Right.
about Quant Connect.
Mhm, mhm,
Um,
mhm.
I'd still mention Zipline and show it a little bit, but wouldn't be like the main kind of go-to thing. Or Backtrader is also no longer maintained, right? So rather like I think if you want to work with be that backtesting or some performance measurement tools, you have a few options. I don't think people need to generate like I don't think there's a need to kind of create new things. I don't think so because most of the things, even if you want to write your own little back tester, I mean it's not that difficult. You know, if I think it's a good test. If you think it's easy and you know how to do it, then you're probably also ready to do some trading. If that is basically an unsurmountable challenge, then you should probably ask yourself if you actually want to risk any money in the market. Because
Yeah,
yeah.
yeah, yeah. That's very true. Very true. Speaking of which, again, these answers are generating questions, so I'm not going down my list. I'm just going on the fly. Speaking of writing your own programs and writing your own packages, is there in your mind, it seems that Python has basically taken over and has proven itself to be the perhaps language for finance, in addition to C++ for legacy reasons, for reasons that you don't want to switch, it's too costly to switch to anything else, Python or something else. That understood. Are there any other languages that you would think going to the future that would come and become important that people can invest now in learning?
So I'm including a little like Rust tool in the book to
Ah,
read like
mm,
order book data. It's a version of C++ in a way in terms of like speed and with some benefits a little more modern. I
yeah.
mean, with I think you need to ask yourself what you really want to do. You can certainly play with it. Like this is a simple tool. I mean, it just like reads data and interprets a few message types and parses them. You can literally, with the help of Chat, I'm not a Rust programmer, right? But like with the help of ChatGPT and some general understanding, you can get pretty far pretty quickly. But that doesn't make you, So I wouldn't want to implement an entire backtester in Rust that then people actually rely on. I think it's doable, but that's a bigger lift. So I think if you want to be a programmer that develops application that really need to be fast, like at the high frequency level, yeah, then you probably want to know more than Python. But that's a substantial job to learn that. So you just want to, be aware what you get yourself into. I think it's promising. I think Rust is very popular. I'm not like a Rust fanboy or so, but I think it's a very reasonable thing to do if you want to get to the lower level piece, maybe a little easier, a little easier to get off the ground than with C++. But again, I think Python is perfectly fine for pretty much every normal type of application. So I wouldn't make
Okay.
that a priority really.
Okay, so that is really, so the answer would be for people who are looking to do that is
Yeah, Python
probably
is fine.
time is better spent learning something else as opposed to
Yeah,
investing in a new programming language. And you're right, Rust, in particular, in the field that I'm active in cybersecurity, it showed up simply because of a better way to manage memory and for
yeah,
the
exactly.
in terms of
Yeah,
cybersecurity, the huge advantage over C and C++, giving you that low level minus the problems that C and C++ have.
yeah,
But I saw recently a book called Finance or Financial Trading or something in Rust. So that's why I
yeah.
also wanted to ask you, like, is that prominent now that people even publish things like finance in Rust? Because it used to be everywhere, finance, C++ for finance, Duffy's books and tons of other books after that for options trading in particular, and
Yeah.
but Python practically can do all of those. I mean, like you don't minus the speed. Okay, minus the speed.
Yeah, I mean, the great thing is with Python that you just don't have to focus that much on the implementation itself. I mean, obviously, you still have to program and everything, but it's still, you can focus more on the subject matter at hand, which is also why probably the C++ people don't take one very serious as a software engineer if you work in Python. But, it's really like, what do you want to do? I think the question with Rust is in the industry, it takes quite some time for these things to really migrate to a new generally accepted platform, because it's generational, right? I mean, the people that are right now are kind of leadership position. They've worked with C++ for decades,
Yes.
right? So they're not just going to hop on a new boat on a whim over the weekend, And also the infrastructure, of course, is there. I mean, that's why you still have COBOL flying around in certain corners, right? Because they are written, they're expensive, and they work.
Yeah, yeah,
And so, right, why reinvent everything just because, somebody says it has certain advantages? So I think these things will eventually change, maybe to Rust or something else that comes around the corner in 5 years, but it's not like, everybody's switching to Rust now in 2 years. Yeah.
yeah, yeah. So I'm gonna maybe ask one or two more questions, and then I'm gonna open up to the audience for them to ask questions, whatever they wish to ask. But one question that was identified is, which machine learning models do you think are currently underutilized in the world of
Mhm.
trading, but that they hold great potential? Like you think that they hold great potential for finance, as opposed to like coming from vision for vision applications or robotics for robotics application, but people are not paying enough attention to.
Hmm. I mean, so yeah, no, I don't have like anything sort of up my sleeve that's kind of the secret weapon, that I think actually the field has expanded quite well. As I mentioned, I really like this whole idea of sort of domain-specific neural networks. Like there's Marcus Pelger in Stanford and Brian Kelly, Yale, I mentioned, and the whole people around them. They've published quite a few interesting things in this area. So I think that is something that can be developed further. I think also it's good advice to, if you can, still keep it simple. So linear models certainly have their place for sure in the noisy world. And in between, you still have your good old gradient boosting as, something that's quite useful. I think that covers a lot of bases. I'm also don't think that the algorithm per se necessarily is kind of the one that really moves the needle there. It's much more the data that you have, how you work with the data, how you like, what exactly are you actually modeling, etc. So I think that is really what matters more than, some Bayesian fancy kind of new way of squeezing the juice out of the data.
Mhm. No, that's a very good point. I think that was going to be one of my questions that I wanted to really see what you thought about this data versus algorithm. I don't want to call it dilemma, but this opposition in some form, even like opposition in the following sense that sometimes people fall in this trap of fancier algorithms a la some other field. So you have seen that, for example, in the world of vision, let's say that this thing has been unbelievably successful, and without regards to its scientific, technical, cultural environment,
Hmm.
you bring it and you want to plant it inside your own garden because you think that this will
Yeah.
also grow here, but it doesn't grow because the data problem. So you're absolutely right. I think data plays a bigger role in the success ultimately, as opposed
Yeah,
to
it's a difficult phenomenon to model, right? I mean, like return if it's returns, right? I mean, there's so many things you can model, right? Volatility, correlations, etc., right? So, but each of them has its own particular challenges, which I think are much greater than differentiating cats from dogs. There's a lot more signal there.
okay.
Or language, right? So the idea of like transformers for finance, I'm not sure that's going to work, as people hope. Maybe some adaptation of it, maybe
Mhm.
some smart way of taking some idea but adapting it, right? So I'm not saying like there's no need to do further research on algorithms. I'm sure that, as I say, adapting neural networks in a way that incorporates like what we know about how sort of signal is maybe transmitted to determine some outcome, maybe more research in that area would be fruitful. But yeah, it's certainly not just cloning something that was successful elsewhere because it's popular and the sort of the current thing.
Yeah, no, no, absolutely right. Because again, one sees all of these techniques, and every day there is something else coming up, and every day there is some other area of mathematics to which it gets linked,
Yeah.
which are wonderful. I mean, I'm not criticizing that. You see the geometric learning, you see manifold learning, you see algebraic geometry coming, topological data analysis coming in,
Mhm.
all the fancy algebraic topology tools are coming in. Just so to know that it's not always the case, the fancier the model, the fancier the mathematics, the better the result for this
Oh
particular
yeah,
problem.
no.
Yeah. because
Not
of
at all. Yeah.
exactly right, exactly right. So one more question before we open it to the audience. Now, supervised learning and reinforcement learning both are discussed in the book. What do you think about the importance going forward of reinforcement learning? I've also seen a couple of other books coming up. How do you see it? Is it going to be successful? Is it modulo certain things to be successful? Is it not going to be successful beyond what it has already achieved?
I mean, I was moderating a discussion last year with Igor Hyperin,
Yeah.
and oh man, I'm so bad with names. Another guy who's actually pretty well known. They're both physicists and have worked on reinforcement extensively. And so from their perspective, they talk a lot about reinforcement learning as, an alternative way to work in like dynamic optimization and, figure out, solutions there that otherwise are hard to come by. That's not really my field. Like I'm not an options specialist. So I was always thinking that, oh yeah, reinforcement learning is kind of the right way to model the market, as agents that interact and all that. But if once you start thinking about like the scale at which you have to really do that to make this actually a proper model of reality, it gets very challenging. And my impression is it got a little quiet
Yes.
around it, which I think just points to the practical implementation challenges of it all. It's something it's extremely appealing.
Yeah.
It's like intuitively makes a lot of sense that that little agent, should just be able to figure this out if there's something to be figured out. But in reality, given like the data challenges, it's quite hard, like it's really the example in the book, if you pay attention, it just memorizes the S&P 500, and then does really well. But like that's not really what we're looking for here. So I don't really know where this is going. That it may be another thing where there may be some breakthrough at some point, or I mean, maybe for portfolio optimization for certain applications, there are ways. But since I'm also not a research person, I'm not tinkering with stuff that is like beyond the frontier to figure out how this works. So I stay more with the stuff that I know has a good chance of being successful. And then however much I personally would be interested in it, I don't really do much work in practice with this just because it's too much of a leap, of
Yeah.
faith.
Yeah, no, that's very
But
true. Yeah, go ahead, please.
what do you think?
Well, I mean, my first encounter with that was with in the work of Michael Kearns from UPenn and his PhD student who wrote a thesis on normative approach to modeling limit order books or something along those lines.
Hmm.
Was the title of PhD thesis. At the time, I was doing my postdoctoral work at University of Pennsylvania in the math department. Of course, they were in the computer information sciences. And so he was working on that, and I saw their paper, and the appeal was very great to me for two reasons. One was that mathematically I found it very pleasing, and the underlying mathematics of it going to optimal control and stochastic optimal control, all of that stuff. Okay, so I found that very interesting, very pleasing, as I said, but I had no idea how well it would work. The appeal of the idea was great that, okay, so I'm
Yeah,
looking
yeah.
at this limit order book, I'm looking at the bids and offers and all these things, and I'm going to figure out and learn from my mistakes of placing the bids and offers and so on, and then I will find my way. And they had some technical 2 or 3 papers. They published a version of it in a handbook for high frequency finance with O'Hara and Easley and I think Marcos. And so their angle was that. So they were pushing for
Yeah.
reinforcement learning for high frequency trading. After that, that went silent. I don't know if the bank they were working with got bankrupt in 2008, Bear Stearns. So
Hmm.
they stopped.
Oh
They
yeah.
had, lab, agent trading lab at UPenn. They stopped that. So I don't know if it was that. With the work with Igor, I don't know how well that will be extendable to everything else beyond options. So in options,
Yeah, I don't. Yeah,
yeah.
yeah,
So, it's interesting again, but I have learned my lesson. My lesson of my research, just like you, I'm not doing research in this field. I'm just interested of these various things that come
yeah.
up and how useful they are. So the lesson I learned very quickly was that the beauty of mathematics practically has nothing to say. about the applicability, and sometimes implementation issues. Sometimes, oh my God, it's amazing. If only we could implement it in an efficient way. I mean, if I can predict
Yeah.
the stock market of tomorrow in a month, I don't think it will be that useful to anybody, right? I mean, like predicting the weather of tomorrow in a month. So things like that. But yeah. Um,
Yeah. Yeah, it seems challenging. It's something we'll say maybe we see in our lifetimes, these things. Because it's such a long path from something being, a concept and somehow published to something that's really being utilized in the industry. So because it's quite costly to make this work, and then given all this stuff that's going on, people have other priorities.
Absolutely right. Absolutely right. And also this, I remember once I was in Chicago at a conference. It's called R Finance or R for Finance. They changed the name later
Okay.
on. They have been going on for
Yeah.
a long, long time. And at first their focus was exclusively R. Now they have brought in Python as the, next of kin. So R and Python. But then Derman came. In one of these keynote speaker was Derman, and he's also background is physics, and he started and worked, of course, in Goldman Sachs for many years. And then he was talking about the advice he had basically was think simple.
Yeah,
People
exactly.
start thinking too complicated, especially those coming from physics and mathematics. They immediately jump into the more complicated models in the hope that that will necessarily lead to better results. No, not like that. So think simple, go with simple, only add if you need, to so.
Exactly. It's my background is actually economics,
Oh,
so in a
okay.
way, so in a way that I think helps. I mean, you always like your own stuff, right?
I've always,
And also you don't know what you don't know. So, but I always think that it's helpful, or at least it helps me to have, in economics, I mean, just as in other sciences as well, but you try to simplify it, abstract, and have like pretty straightforward models that capture like the salient facts, and that certainly is useful. I mean, it's always, the more complex the thing you're modeling, the less sort of adequate these things are. But in finance per se, where a lot of noise is there, trying to focus on a few things and get them right sometimes can be helpful. So
and you're right on what you just said, to get them right sometimes. Because I remember, so Marcos was in one of these conversations with us a couple of weeks ago.
yeah.
And when we were talking to him, I remember he said something very interesting. Again, something which is so counter, I would say, intuitive to a mathematician's mind. Not so much physicist, but perhaps economics as well. Because he said, look, you don't even, so these models that we start with something simple, we pay attention to data, the nature of data, what data is trying to tell us. Okay, take that
Yeah.
seriously, try to work. Okay. But then he also said, and remember, your models, you don't even have to be right all the time. You have to be right
All
enough
right.
times to make money. So for a mathematician, like either it's a theorem or it's not a theorem. Like it can be
Yeah,
theorem.
yeah, yeah,
We
yeah.
can, and these are really, I think, cultural, I won't say shocks, but cultural discrepancies that you see for somebody from physics, economics, especially theoretical mathematical economics, coming into
Yeah.
the field and feeling uncomfortable initially with the way that things are. But okay, so I'm going to
Yeah,
open.
somebody said all models are wrong, but some are useful,
Some are useful
so it's
in
kind of
that sense. Yeah. Some are useful some of the time. Enough.
yeah, exactly.
Some of the time. All right. So, audience, please, we are few of us. So, I please unmute and ask your question. And there's already a question from Patrick. If you want, I can ask it for you. But if you want, just unmute and ask. Okay. So, I will probably ask Patrick's question. Does the author see any particularly interesting applications of machine learning to market risk predictions for individual assets and portfolios, specifically the input features, training algorithm, and output values? Thanks for the interesting discussion. So that's it.
Yeah, many things in one, like risk for individual assets, like what exactly does that mean? Is it volatility, right? Or downside risk or so? I mean, certainly you can, just like you could try to predict returns, you can predict, any, value in the distribution or so. Volatility models are popular anyway. So clearly there are applications, but again, as we just said, like ultimately like some models are useful. What exactly are we modeling? Like what exactly is, how do you define risk? Do you want to model like the correlation between certain assets? That's the question? Then, it's a different kind of model where the standard supervised, have one output maybe a little less appropriate, so I have to maybe think a little harder about how to actually capture the phenomenon. But that's really kind of the it's a good example, I think, how where you see that it's not so much what is the right model that I load from scikit-learn to kind of do it, but it's more like what exactly am I actually trying to capture? What metric, what phenomenon, what actual sort of phenomenon in the real world, and what data would speak to that, And once I have that, when I have a kind of a mental model of that relationship, then I can find maybe an algorithm that is good at representing, the structure. So I think it's more, it helps, I think, always to see machine learning as a broad toolbox, that is capable of modeling a bunch of different things, but it's more really the main task to really be clear about what that task is and that model, and take it from that end.
Oh, okay, okay. Yeah, thank you so much. Yeah, I really want to say like a big thank you for Mr. Jason. Yeah, I'm a fan of you. So it's been like your book is like being like a Bible for me for all the quantitative trading. Like for the past 3 or 4 years, I already read it like
Wow.
3 or 4 times already. And yeah, I all found out especially the GitHub repo with the source code is super incredibly helpful. Yeah, because you cannot get the whole things until I really run the code by yourself, because you will find a lot of Python version issue, a lot of data set is now being there. So I really want to say here, thank you so much here. And also like, I try to testing like also book our different direction of the quantum trading. I found like there are kind of two direction right now. One is kind of focused on the alpha, which is kind of all the features, right? You want to, which features you want to pull, get the information from. And the other right direction is finding kind of the best model, because I know like, yeah, whether you're using like a supervised, unsupervised reinforcement, or on top of using deep learning, you want to always find like a better model, right? So there are kind of two directions here. One is you focus on finding the most information source, which is the features, right? Whether you textual or unstructured data. And on the other side,
Yeah.
you want to find a better model, right? But you have, people have energy, have limitation. What's your viewpoint? Like which direction, like can be should we going for like to put more effort on it to better to create a model and capture, the kind of do a better accuracy or prediction, or risk management in future. Thank you.
Sorry, were you saying for risk management in particular, or what are you trying? What are you trying
like
to
also
model?
more or general the prediction accuracy, like winning rates or IRIC, those like which one
Okay.
kind of which route we should go
Okay.
for is more better. Yeah. Thank you.
Yeah. Yeah. I think really it's sort of taking it from the top. I mean, the bigger questions, the biggest questions are like, what actually sort of do you want to exactly predict? Like, what's the horizon? So what's the asset class? What's the horizon? Where in that asset class, for instance, do you want to position yourself, and all that driven really by where do you have some type of edge, some informational advantage, some insight, that you think allows you to, be ahead of the pack, and the pack can be very small, if you do like small caps and maybe some emerging markets, it's an entirely different story than trying to trade Nvidia and Apple or so, right? So I think that really is kind of very important. And then very closely related to that, of course, what information sources do you use, right? As we said earlier, like the kind of data, if you are well placed, or if you have some insights into data that is harder to work with, that either be that larger data set, like some proprietary data sets, of course, harder for the retail investor, or text data, that may contain information for the time horizon that you care about, which can be 5 seconds or 5 months, I think that really is kind of where the music really plays. Once you're confident that you have a data source that really contains information about what you're trying to predict, right? Whether the returns are positive or negative and how large they are, sure, then it does matter what kind of model you use. But very often I find that the choice for a model is often dictated by the data that you have, right? I mean, if it's like very large and unstructured, or it contains language, then you probably not going to work with a linear regression, but rather look really for something like a transformer type of model if it's language, right? And if you have some larger sort of tabular data with potentially a lot of interactions or so, then maybe something around gradient boosting trees is not the worst place to start with. Maybe you want an ensemble, right? Maybe you have a combination of these things, and then maybe you could integrate different sources. But as we said earlier, right? I mean, it's you can sort of get sidetracked by trying to find your salvation by getting to the right algorithm, when I think really it's figuring out what is it that you want to predict and what is the most predictive source of information for that. I think once you have that, even running with the third or fourth best algorithm probably is going to be better than to have very poor information and really making it to the best algorithm, because it's still not going to be the IC is going to be low, right? If you ask for the IC, just because there isn't much information content really.
Thank you so much. I got it. So kind of like the kind of domain knowledge, or like whether you can choose the right information actually come first, right? You have to make sure you get more like a domain knowledge, choose the bad features and understand where the information come from. That's the priority. And then once you get those things information enough, then like you can just test in all the model, right? So don't testing all the model to get a result, maybe it's just overfit, right? But you actually don't get additional information. That become another trap, right? So got it. Thank you, appreciate it.
Yeah, I mean, there's this whole story with, the free lunch kind of theory and all that story, right? Like, a priori, it's not really clear which algorithm is kind of best, but, it helps to have some, this inductive bias kind of idea, where if you match the right algorithm to kind of the way the data really relates to the outcome, then you have a chance, right? If the relationships are simple and more linear in nature, as opposed to something where you have to really extract the feature from this large unstructured set of data. So as I said, very often the data that you have really, if you understand it properly, takes you to the right family of algorithms pretty quickly. I'm not saying it's easy, but I think it's much easier than actually figuring out what good information is. So yeah, you're right. Domain knowledge comes first, second, and third probably and creativity, creativity about like how do you transform the data and all that. It's not just like studying finance, right? But it's understanding what really drives the prices of these specific things, what could be predictive, and then working with that data in an ingenious way.
Perfect. Thank you. So while you're thinking about the questions, let me ask one. This is large language models and natural language processing, and your thoughts on that. Chapters of the book, of course, but now beyond that, things have evolved so quickly that
Oh yeah.
I wonder how you see it, where you see it.
I mean, yeah. So the book, there's this brief introduction, right? Like go from the back of word stuff to the embeddings. Like I've been a fan of natural language processing for more than 10 years. Obviously I'm from Germany originally, and I've lived around the world. I speak several languages, so I've always been interested in language per se. And so, once I saw this word2vec sort of paper where you could translate these vector relationships from one language to another, and I found that pretty interesting. So that's why that's in the book, right? That's of course outdated, and thankfully we have lived through interesting times with a lot of progress, which is really specifically tailored to language, which has its role in finance. It's certainly not the central piece. I think we're dealing more with numerical data, at least so far. Of course, the big question is that simply because that is what we could work with, when actually a lot of information is also in use, etc. So I think the main applications right now that I see for the large language model is almost more like these interactive research kind of tools. I think that is kind of where they really shine at this point in time, rather than also given the latency and everything, and a lot of like trading applications per se, but just like you can use this to support a fundamental researcher and like summarizing all sorts of things and drawing conclusions and making suggestions, you certainly can, and people will be embedding this in models, just like Google uses this to improve your search experience. Just like that, you can certainly make better sense of the text data that surrounds your objects of interest using language models. So I think it's starting to be phased in, in areas where people make sense, be that like it's a credit, right? I mean, if you invest in credit, you have a lot to do with contracts and the like. So that certainly is one area where text data is or large language model will contribute to trading decisions. Whether that is in a fully automated way, I'm not sure, but certainly in the decision-making process where things are semi-automatic, or let's say more you automate business processes maybe rather than the trading process itself entirely,
Yeah.
So
Yeah. And we did discuss this a little bit. You mentioned this on passing, but what about GANs and synthetic data approaches that more and more, like 2, 3 days ago, even I saw something from England by a group under Ramakont on synthetic options data or things like that. So do you think this can play a role really like what we would use Monte Carlo simulation for? Like now we go and say, I don't know, do a synthetic data generation for how you see with all the news and everything about DAX, with Germany and events in Germany and everything and the politics and everything going on. Show me how it is going to go. Give me another alternative. Give me. So I wonder, I mean, used to be you go to and draw from normal Gaussian data and you play with that.
yeah,
But now it can be serious, although I don't know.
I think that is also one area that's really under heavy experimentation. I wouldn't be surprised if, you find for a bunch of applications synthetic data that is good enough. It's again always like, what is the bar that you need to meet? Is is it going to generate data where everybody says this is faithful of what the market generates? I'm not sure, but this it's very, I mean, the language model synthetic data, of course, they're very good for what you just mentioned, right? Like exploring scenarios, like getting unstuck, they sort of, just like let's say areas where the hallucinations, can actually be a positive thing,
Of course.
I think that is where that helps. On the quantitative side, like the GANs, I think that is really difficult, and I'm not sure. So we're certainly not there now at this point. This is a different thing, and that the time GAN example that was really based on medical data, right? To like generate medical data based on like measurements of patients, and to develop an early warning systems where because of privacy issues, you couldn't get as many data as you wanted. That type of data is probably a little more regular, and just like with images, again, you have more signal that you can capture and imitate. So the typical financial data with the noise, if you really want to like generate a ton of equity returns, I'm not sure that's going to fly. But also, I don't know. I think it's possible to get close enough
Mhm.
where you say you have so much data, even though the data isn't like 100% accurate, maybe that still gives you kind of an edge. I think I would say it's worth enough trying that certainly people are trying right now, and maybe somebody succeeds. But again, it's beyond the current frontier of things that are established.
Yeah, no, it seems definitely that something, you're absolutely right. They are trying the same way that it has slowed down a little bit the trials on time series analysis using large language models after the controversial
Yeah,
things results on archive. There was all sorts of things against the Cornell paper and things like this. So but nevertheless I think it's a good thing, although one needs to be aware and one really has to have very good filters. What is really meaningful, what is really applicable, what is really, even if it is good and applicable, do I want to apply and put my money behind it, which becomes the most
yeah,
important question. Somebody else's money maybe, but do I want to put my own money? So those are, but people are trying and they will keep trying. When I see that, forever I have been mystified, if that is the right word, by what I read about Renaissance technologies
Hmm.
and Hyman's work. Because when I was looking at this, even very, very, very rudimentary articles that came out many years ago, up until even the book by Zuckerman and all the other things, pointed in the direction that the main hirings were happening from the IBM's language group. And their main thing that they were doing, like the Mercer, like Brown,
Yeah,
Peter Brown, they were doing speech recognition, automated
yeah,
translation.
yeah,
So you keep wondering, like, because those were the large language models of that era. Like you were
yeah.
basically using the hidden Markov models. is there something like that going on that we are not able to see with these large language models? Or is it that the idea was already utilized and the main idea was what they were doing already with smaller models? Forever I'm mystified. I can never get to the bottom of it.
Yeah, I don't think, yeah, I can't claim that I know. I think, but I do think that the Mercers and so they were also, the folks that said that every time they fire a linguist and hire a statistician, the model gets a little better, you know. So so I think they were kind of really at the cusp where machine learning went from that rule-based or where AI, not machine learning, right? Where
Right,
AI
right,
went
yes.
kind of from this idea of, we just like gonna like code all the rules and then we got a little human here to something that we learn from data. And I think it's really that idea that translates, that you actually learn. That's why they hire all these like astronomers and other people that really work with large data sets, and are used to finding tiny effects there, you know. I think that is, and if you think about like how early they started and they had
Yes.
the best data and they just like had such a head start and the talent. I mean, that's kind of that happens once in 100 years, that you
Very
occupy one lucrative spot in the world on your own
true.
with the right people. That's I don't think it's going to happen anymore today. But
No,
yeah,
no, you're
more power
absolutely
to
right. But
them.
that point is a very, very nice point you made. I think you're so right on that, that they were really at a point where we were doing sort of a paradigm shift in AI
Yeah,
from
yeah,
the
exactly.
logic people and logicians and all the rule-based people to more of the let us jump into the pool of data and learn from data
Yeah,
transition. And that transition, plus everything you said, the talent, the data, because they talk about that, how much data they had back then, even, and how good the data was, quality of the data. I don't remember the name of the person, but he was there for many, many
yeah,
years.
yeah, yeah.
But he had all these things accumulated in notes and things like, I mean, it's just amazing. But yeah, it's also being able to capitalize on all of that, which was a good managerial skills, I suppose. So I have two questions left. I think one is I hear also JP Morgan being probably the most flashy news in recent days on the quantum advance that they have made in algorithmic use of quantum computing in certain things that relate to finance. But what are your views on that? Do you think quantum will really be as impactful as high performance computing is or has been? Or is it okay, you can do it faster, but who cares really? I mean, I'm fast enough. I really don't know.
Yeah, me neither. I looked at it. I have a friend
Yeah, JP
literally
Morgan, yeah.
from not primary school, but shortly after, who had a successful exit from a startup, and he has a quantum computing company that's actually about like providing a platform so that folks can
Oh,
try out quantum algorithms. It's not they don't do quantum computers, but they say you can simulate quantum algorithms to prepare. They come from the optimization background. Yeah. So I was like talking to these folks for a little and looking at it, and I just like, to me it just seems everything is like that's way beyond the horizon that's relevant for me in terms of practical applications. So it's more like speculative. I'm sure, I think like many other things, it seems entirely possible to be useful. For what exactly, I think people are debating, but also it will not be here in the next 5 years for sure. So that means I'm not going to spend like a ton of time, because I'm not a physicist, so it's not like I'm a quantum guy by nature. So I have a high level understanding of it, but I don't see that being relevant like near term. In 15 years, that's a whole different story. But then there's
no,
time to get into that.
of course. For those who want to get into that. Yes, indeed.
Yeah, yeah, exactly.
So that brings us to my last question, which I always ask, and that is what advice do you have for people in the community, especially for younger people who are right at the start of their journey to become a quant or quant related jobs, aspiring quant finance workers, and people who just like this field? What advice do you have in any sense or term, like books or learning material, whatever you think?
Yeah, more than anything, I think you actually have to trade. So you actually, you have to learn about the sort of the bread and butter of the field. You know, like we talked about market microstructure at the beginning, but not necessarily in the the abstract things in the model. That's all interesting, but you actually have to be engaged in sitting there and seeing how the market works, what it means to place orders, what happens. Then you get much more attuned kind of to the actual sort of reality of it. You know, I think finance is a field where it's very easy to just spend time and time reading models and diving deeper into the math. And I personally also like it. That's what I originally liked about it. But that is far removed from the daily reality. So I think do both by all means. You know, obviously math and the methods and all that totally matters. Statistics is very important, but don't get sidetracked by sort of all these shiny objects, you know, which is very easy. Really, you know, put some money of your own to work in some way just for experimentation. Don't lose your shirt, but, you know, just to actually be engaged, get a brokerage account, you know, and do something, you know, try to automate something, you know, try to get hooked up to some API, you know, and think about how could you actually automate some trades, you know, be that with simple indicators, just like thinking through that actual flow of events, you know, is going to change your view on all the theory and everything quite a bit, because you would ask much more, how is that actually going to be relevant? You know, as I go through these motions, how can that be implemented? So it's really going to sharpen your views on the practical matters, which is ultimately, if you want to do that for a living in some way, is really, really important. You know, it's so yeah, so no book recommendations, except of course my own. um, but really much more get your hands dirty and really learn, like get an Alpaca Interactive Brokers or what have you kind of set up and just get going, you know, and see what you learn. Maybe you actually realize you actually don't like it all that much.
No,
You
right,
know?
that's also true. Yeah, you're absolutely right. Maybe after all, you know, if the love is in some other place, so to speak, misplaced in quotes, then it is much better to learn about that sooner than later. Yeah. Yeah. Very good advice. Very good advice. Well, thank you very much for everything. This was absolutely a wonderful conversation. Thank you for spending an hour with us this evening. And we will be in touch, of course, and we will let you know how readership of your book is evolving, at least in this community. And other things,
Thank
please,
you.
you know, let us know if there is anything that community can help in any form or shape. You know, if you had ideas that you know, crowdsourcing makes sense to you, or reading, giving
Yeah.
back of anything of that sort, please let us know. We'll be happy to
Yeah,
participate.
we'll do. I was planning, I mean, obviously, I planned to start with a revision a while ago, but you know, other things go on. But yeah, I think as I progress with that, I might be sharing like more information about, like, you know, what's going to be in it, what's going to change, and sure, you know, get some input on that might be useful. Maybe somebody wants to look at them, wants to review certain things, get feedback, you know, who knows. But
Yeah,
yeah, maybe there's scope for there's room for some more dialogue around that going forward.
absolutely.
But yeah, thanks for having me.
Go, of
It's been
course,
a
of
pleasure.
course. Thank you. All right. Have a great week and a great night. All right. Bye.
Thanks, you too.
Thank you, everyone.
Bye.
Bye.